Now here is a formula for development length. LD mean development length, it should be equal to this thing. So development length is some fraction of the dia bar. And this whole thing will be equal to some fractional value. Now here, all these variables are clear. This factor CV plus KTR divided by DB is the confinement term, and it should not be taken greater than 2.5. So this whole thing is has maximum value of 2.5. Now these things are actually modification factors, and value are given here in this table. Table 25.4.2.4, modification factor for development of deformed bars and deformed wires in tension. So for lightweight concrete, we have to take lambda equal to 0.75. For lightweight concrete, where ST is specified. So these are the factor values. Now epoxy value, size, and casting position. These three are the variable mentioned there in the formula. These three having the corresponding value under different conditions. So just see the condition here, and all these values are somewhere around 1, 1.5, and 0.8. Casting position, size, and epoxy. Now the equation mentioned there can be further simplified, and section 25.4.2.2 recognize that many current practical construction cases utilize spacing and covered value along with the confining reinforcement such as stirrup ties that result in a value this equal to around 1.5. Mean for the current practices, we should take this factor CV plus KTR divided by DB to 1.5. But remember, previously we mentioned that maximum value should be 2.5. But for the current practice, it's saying that, quote saying that it should be equal to 1.5. For other cases, it can be taken equal to 1. Based on these value of 1.5 and 1, equation above can be simplified as given in the next slide. So this equation can be further simplified for number 6 and smaller bars. The equation can be written like this, and for number 7 and larger bar, it can be written like this. Here is 25 and here is 20. Now here is a different number of bars, and for grade 40 and 60, these are the development lengths. Again, here is some cases specified into some these cases and this specification, and for other case, both are given. So just read it out. These are the values in inches. Development length for the reinforcement in inches. Normally we using number 4 bar, so number 4 bar under grade 40 steel, we should minimum use the value 15 inches. For grade 60, we should mention we should give 22 inches. This is a ACI table provisions for development of tension reinforcement. So for 3000 psi, LD, so the formula for development length can be further simplified into this form. For grade 40 steel, under bar number 6 and below, development length should be equal to 32 into dia bar, and for grade 60 it should be 245 into dia bar. Similarly, here are some conditions. So for other condition, it should be like this. For for bar number 7 and above, under grade 40 it should be 36 into dia bar, and for 60 it should be 55 into dia bar. So these are the simplified results for the above formula under different conditions. Better to memorize these video target 40 and 60 and corresponding below number 6 and above number 7, number 7 and above was. The same provision for development attention person. Further reduction in development length. Development length can be reduced by increasing the term this in the denominator of the equation. So in the above equation there was this term, and we mentioned that video should be 2.5. Then later on we reduced this to 1.5 under practical cases of construction, and even we can use 1. C is the this formula. C is the measure of either of the distance of the center of the bar to the nearest concrete surface, or 1/2 of the center to center spacing of the bars being developed. Bar with minimum clear cover not less than 2 dB, and minimum clear spacing not less than 4 dB, and without confining reinforcement should have a value of 2.5. Therefore, LD can be further reduced by substituting the value of 2.5 instead of 1.5 in the equation. So, as this video, whenever this value of this parameter increasing, so development length will be decreasing. So, whenever you should put 2.5 instead of 1.5 or 1, this value will further reduced. Now, is here provision for development of standard hook and tension. Development length under hooks in inches or deformed bar and tension terminating in a standard hook shall be greater of so development length under hook should be equal to either this or this or this. So hook should the greater of these three should be equal to the hook length. So it is here 8 times a dive bar or 6 inch or this equation. So the least one will be the great volume will be equal to the hook length. For the calculation of length of development length per hook, multiplication factor shall be in accordance with the table. This one. So here are all these factors based on the same formula. For a bar being developed by a standard hook at discontinuous ends of the members with both ends cover and top and bottom cover to hook less than 2.5 inch. So this should be satisfied. First one is hook shall be enclosed along this development length within ties or stirrup perpendicular to this. So these are the 3 conditions and should be satisfied. Just see it by yourself. And here is some simplified views for grade 40 and grade 60. So for hook length, if you're using number 3 bar under a grade 40, it should be equal to 6 inch. And so as the bar size increasing, the hook length increasing. Here is a some hook. This is a 90 angle hook, and it is a here is a 180 angle hook, and everything is mentioned here. This is a dive bar. Hook length should be equal to 12 into dive bar per 90, and par number 3 to number 8 it should be 4 into dive bar. Par number 9, 10, and 11 it should be 5 into dive bar, and par 14 up to 18 it should be 6 times of dive bar. I mean this length. But the minimum value is 2.5 inch for this part. For this part. Here is some generalized formula for hook length. For grade 40, generally we should take it 16 into dia bar. For grade 68, we should take it 22 into dia bar. Minimum inside bent diameter or bar used as transverse reinforcement, and standard hook or bar used to anchor stirrups, prize hoops, and spiral shall conform to this table. Standard hook shall enclose longitudinal reinforcement. So here is a per 90-degree hook, per 135 hook, and per 180-degree hook. Minimum inside bend diameter should be like this. So this bend diameter minimum should be like this. Here is bar number, and here is a diameter, bend diameter. And here is straight extension. So just see this table by yourself. Under different degree of bend, now very scenario where development then hook development then must be satisfied. Here is a simple 90 bend of 90 degree. Here is a column, here is a beam, and this hook length or development of bend reinforcement in column shall be greater than LDH. Now these are the beam reinforcement. Beam is up to here. It should extend, and this extension should be greater than LDH. Now what about the column? The column is up to here. There is a common joint. So this length for the column should be equal greater than LDH. Now for the foundation, here is a development length. Now let's come to splices of demand bars. Splices mean to join. In general, reinforcing bars are stocked by supplier in length up to 60 feet. Generally, the supplier bringing us steel up to length equal to 60 feet. For this reason, and because it is often more convenient to work with this shorter bar length, it is frequently necessary to splice bar. Splices in the reinforcement at the point of minimum stress could be avoided. Splices should be staggered. So this point number third saying that we should identify the point where maximum stresses are developed, and we should not uh, provide splices there. We should avoid these points. Splices can be done in three ways: lap splice, mechanical splice, and welded splice. These are the lap splices where two bars are extended to one another. For the lap splice, according to this provision, minimum length of lap or tension lap splice shall be as required for class A and B splice, but not less than 12 inch. So for class A splice, it should be 1 into development length. For class B splice, it should be 1.3 per development length. Development length we already discussed earlier. Splices for the palm bars. So just to read out this discussion. Here is mechanical splice and welded splice. Welder splice mean when two bars are face to face welded. So just see the last few slides by yourself, and it's end of this lecture. It's a long lecture. References are here from ACI, ACI 318, ACI Committee 435, and Design of Concrete Structure by Nelson. So the book chapter 5 and 6. Thank you. See you in next.